Hello, everybody. We're looking at lesson 24 here. Molecular geometry is the title of this. So with this one, you're going to need to draw Lewis structures, and from there, there's a way to figure out what kind of shape it's gonna make. So the idea here is the opposite charges will attract, and similar charges will repel. So what that means is if I have a atom and it is connecting to another atom. So let me actually do something real. So the idea right here is that if you have, we'll say with carbon, and it's bonded to a bunch of hydrogens, it would never do this right here because remember, a bond is made up of two electrons together. And so these electrons right here, they have to be together because they're what make this bond happen. But the electrons that are part of this bond, they don't have to be next to that. And since electrons are negative, they repel. They don't want to be around each other. So there's no way this would ever happen. The idea is this is going to spread out so that you have it where the hydrogens get as far away from each other as possible. Now that's what it looks like in 2 dimensions on a flat piece of paper or a flat board. The idea here is that in reality, it's going to take some different shapes, and that's what we're going to learn about today. So if we look, so the types of shapes that covalently bounded compounds can form is going to be limited by this reality right here. And so we have this VSEPR theory, the valence shell electron pair repulsion theory, that allows us to determine what kind of shapes we're going to see. So the areas of electron density that repel each other are basically going to be electrons and bonds. So we're going to have 5 shapes: tetrahedral, pyramidal, bent, linear, trigonal, planar. Okay, those are the 5 shapes we're going to look at today. So the first shape will be tetrahedral. An example of that would be CCl4, or the one I just did, which is CH4. What you have is you have 4 bonds that all repel each other. And so the idea, I'll stick with the example it has there. If I have C, so the idea is that the bonds right here are loaded with electrons, and so they repel each other. However, in 3 dimensions, what you're actually going to have is going to look more like this. Because I want you to think, if you take this and all you have is just a cross-looking thing, there's a lot of wasted space, because if you're in 3 dimensions, there's more that you can do with it. So what it will actually look like is you'll have the carbon right here, you'll have 1 chlorine pointed straight up, and then I want you to imagine that me drawing this thing shaded in means it's sticking out and it's coming towards us. So it's kind of sticking outward like this. And you'll have 1 right here, and then you'll have 1 going away from us. So the one not shaded goes away from us. You'll have 1 kind of going back at an angle like that over here, and 1 going back at an angle like that over here. So you almost have like a really wide tripod and then 1 sticking up in the middle. Okay, so in fact, if I could, let me try to, it will look something like this. What I'm saying is that instead of, to get these as far away from each other as possible, instead of doing a cross like this, right? Instead of doing that, that's what it looks like on paper. And if you draw, when you have 1 in the middle, 4 on the outside, if you draw it like this on paper, I'm okay with that. Just understand that in reality, what's going to happen is you're going to take these and spread them out equally in a almost like a tripod, and then you have 1 sticking up like that. That is what allows them to all be the furthest distance possible from each other, is have 3 pointing down and then 1 sticking up. That is how I'm going to get these different areas of electron density as far away from each other as possible. It's definitely the hardest one to demonstrate. So that's tetrahedral. So anytime you have 1 central atom and 4 on the outside, you'll make a tetrahedral. Now this is going to be trigonal planar. With this, the example is CH2O. So what's going to happen for this one, let me find there we go, this pen works well. So CH2O. So what's going to happen, we have carbon with 1, 2, 3, 4 electrons. It'll double bond with the O, and then it single bonds with the H. So what I have carbon making 3 bonds. Yes, I know that's a double, but those all have to stay together. They can't split up because they all have to be between carbon and oxygen. So what's going to happen here, they will arrange like this, with one pointing up, one pointing to the side, and one pointing to the side, but those are at a downward angle. So it's almost, that's why it's called trigonal planar, because if you make it into a triangle, it's a bit of a triangle right there. So anytime you have one atom in the middle bonded to 3 atoms, it's going to be trigonal planar. Okay, and then we have linear. There's 2 types of linears, right here and right here. So one of them is CO2, which would be like this. If I have C with 4 electrons, it's going to double bond to an O and then double bond to an O. And so since I have carbon double bonding to O, carbon double bonding to O, there's no extra electrons on carbon, so they go in 2 different directions like that, making a line, which is why we call it linear. Another example of linear would be if I have something like H and then just say Cl. Well, and that, because there's no other, I mean, it's going to be a line no matter what. Like we're talking, if you go from tip to tip, I mean, it's always a line no matter where you're pointing. So linear is either going to be if I have just 2 atoms bonded together, or if I have 1 in the middle, 2 on the outside, and no electrons on the middle element. So far we have, if you have, in fact, let me recap it like this. If I have 1 in the middle, and I'm bonded to just 2 other elements, it's going to be linear. If I have 1 in the middle and I'm bonded to 3 other atoms, it's going to be trigonal planar. And then lastly, if I have 1 in the middle and I'm bonded to 4 outer atoms, it's going to be tetrahedral. Okay? This is all assuming that there are no extra electrons in the middle atom messing things up. Okay? Now we have 2 more shapes to look at. And for these 2 shapes, things are going to change up a little bit. Let's look at when we have bent. H2O is our example of bent. What's going to happen for bent? We have H, which will bond to the O. Let's have another H. Okay, you might look at this and think, oh, it's going to go like this. O, H, H. And you might think, oh, it's going to be linear. However, I want you to remember, this is in 3 dimensions. So what would happen to use those 3 dimensions, even if you do it like that, this stays on top. Remember, the electrons right here would be kind of going towards us. And then this hydrogen is going to be kind of away from us. And this hydrogen will be away from us. Or if you make it, say the electrons are right here, and then this is the hydrogen, it'll look like that. Or if you put the hydrogen right here, put electrons right here. Either way, no matter what the configuration is, because remember what I'm saying we're doing is we have this whole tetrahedral arrangement, which is what's best, the way these can be furthest away from each other in 3 dimensions, is to make this tripod in the bottom with then with one sticking up. Now take these away and imagine these are electrons. There's 2 electrons right here, 2 right here. It still pushes these away, but they end up just looking bent, right? They can't go in a straight line because the electrons are still there. So that might be a bit confusing. The thing I want you to understand is if you have 2 atoms bonded to your middle atom, but the middle has extra electrons, it ends up looking like that. So when we draw it, we can just go ahead and draw it like that. I mean, that also would be okay. I take that answer. But we call that bent. What's the difference between bent and linear? Look. Here we have C. Here we have CO2. And here we have H2O. What's the difference? This will be linear, that will be bent. Look at the difference. Actually, on the screen, it might be hard for you to see. I'll draw these bigger. Notice you have extra electrons on your oxygen. Those push the hydrogens away, making it bent. Carbon, did it have any extra electrons? No, all of them are used in bonding. So if you gave this a positive 4 charge, if you're able to remove those, then yeah, this is going to go ahead and scoot out here. It would be linear. But in this case, it has to be bent. So that's bent, and then we have one more shape to look at. One more shape. So also with this, it can either be when you have 2 electrons or 4 electrons, and that'll change the angle, but we're not going to focus so much on that. Lastly would be something like NH3. So we'll have N. This, we don't get to be trigonal planar because we have N will look like this, and so it'll go like this. We'll have H, we'll have H, we'll have H. In 3 dimensions, remember, these will spread out from each other, and then you have one point on top. In this case, the point on top is the electrons, so they push them away, though they don't add to the shape. That's why it looks like a pyramid, so it's pyramidal. So what's the difference between NH3 and something like, let me see, what was the, it was C, O, and then we have H, and we have H. So if we have, for example, you know what? It's in the middle of the glare. You can't even really see that. So if we have C double bonded to O, and then we have an H, and we have an H. So right here, this is going to be pyramidal because the electrons up there are repelling it. But look at this. They both have one center atom bonded to 3 outer atoms. Here, one center, 3 on the outside. This, however, will be trigonal planar because there's no extra electrons on the C. All right, so that's what we go through to do that. So I want you to try to use this video, try to answer the questions on your, the questions that you have right there, the questions below this video. And then what I'll do is I'll go over the answers this time, and I'll have a second video attached where I go over all of the answers and help you out with that.